हेलो एवरीवन, वेलकम बैक टू अवर चैनल इंक्रीमेंट्स। हमारी पिछली वीडियो में हमने पल्मोनरी फंक्शन टेस्ट के बारे में पढ़ा था, जिसको हम लंग फंक्शन टेस्ट ही बोलते हैं। इसके अंदर 5 थिंग्स वी मेजर, दैट इज लंग स्ट्रेंथ, लंग वॉल्यूम, ट्रांसफर फैक्टर, arterial और blood gas analysis and oximetry, और एक्सरसाइज टेस्ट। ये पांचों चीज़ें हम पल्मोनरी फंक्शन टेस्ट के अंदर देखते हैं, जो हमें पिछले वीडियो में थी। आज की इस वीडियो में हम बात करेंगे लंग स्ट्रेंथ पे। बेसिकली लंग स्ट्रेंथ क्या है? लंग स्ट्रेंथ को जनरली हम मेजर करते हैं स्पायरोमेट्री के। स्पायरोमेट्री क्या है? स्पायरोमेट्री नॉन इन्वेजिव टेस्ट that is done to identify or diagnose disease. स्पायरोमेट्री समझने से पहले और लंग स्ट्रेंथ समझने से पहले हमें 4 वैल्यूज़ को ध्यान रखना होगा, जो है FEV1, FVC, FEV12, FVC रेशियो एंड टोटल लंग कैप्स। ये चारों वैल्यू हमें बताएगी कि हमारा लंग नॉर्मल है, ऑब्स्ट्रक्टिव फेज में है या रिस्ट्रिक्टिव फेज में। तो स्पायरोमेट्री हमने बेसिकली 3 चीज़ों के बारे में बताती। ना पहले इन 3 चीज़ों को समझने से पहले समझ लेते हैं कि FEV1 क्या है, FVC क्या है, FEV1 to FVC रेशियो क्या है और TLC क्या होती है। FEV1 is a normal amount of air that you exhale after a forceful or deep inspiration in 1 second। जो फर्स्ट सेकेंड में आप गहरी सांस लेने के बाद सांस छोड़ते हैं उसे हम कहते हैं FEV1। FVC is the maximum amount of air you exhale after a deep inspiration, उसे हम FVC कहते हैं। FEV1 to FVC इन दोनों का रेशियो है, और TLC टोटल लंग कैपेसिटी, जो आपकी लंग की कैपेसिटी है इंक्लूडिंग ऑल दी 4 वॉल्यूम्स, जो हमने पिछले वीडियो में बात करी थी। अब इन्हें नॉर्मल लंग, तो FEV1 is generally more than 80%, FVC ratio और FVC is more than 70% और 80%। जनरली इसकी रेंज 80 to 120% होती है। FEV1 to FVC ratio is generally more than 0.8 and TLC in normal lung is 6 liter। जब भी अगर स्पायरोमेट्री परफॉर्म करोगे या स्पायरोमेट्री करोगे तो आपको 2 चीज़ें देखने को मिलेगी। Either you have an obstructive condition or you have a restrictive condition। Now, obstructive case, ऑब्स्ट्रक्टिव केस क्या होता है? जनरली ऑब्स्ट्रक्टिव डिजीज, ऑब्स्ट्रक्टिव कौन सी होती है? 4 ऑब्स्ट्रक्टिव डिजीज है आपकी, जनरली अस्थमा, COPD, सिस्टिक फाइब्रोसिस एंड ब्रोंकाइटिस। ये आपको ऑब्स्ट्रक्टिव कंडीशन में देखने को मिलती है। restrictive के अंदर मतलब कि diffuse pulmonary lung disease, also known as interstitial lung disease, chest disorder such as kyphosis, scoliosis, neurosis, and neuromuscular disorder such as polio and other conditions. So these are the conditions that concern obstructive and restrictive condition. What are you going to see after performing a spirometry? So in cases of obstructive condition, your FEV1 will be decreased. Your FVC also decreased. Your FEV1 to FVC ratio is generally decreased, and your TLC is increased in obstructive condition. While in case of restrictive condition, जो FEV1 वैल्यू है जनरली डिक्रीज होती है पर इतनी अमाउंट डिक्रीज नहीं होती. FVC वैल्यू है वो मोर अमाउंट में ज़्यादा अमाउंट में कम होती है. FEV1 और FVC रेशियो जनरली नॉर्मल देखने को मिलता है, और जो आपकी TLC है वो कम हो जाती है. तो ये डिफरेंस है ऑब्स्ट्रक्टिव और रिस्ट्रिक्टिव पल्मोनरी डिसीज़ के अंदर. अभी हम इन सब वैल्यू को ग्राफ की मदद समझेंगे. सो इट वुड बी इजी फॉर यू. लेट्स टेक a graph. This is an x-axis and this is a y-axis. The x-axis represent time and the y-axis represent volume. So the x-axis represent time and the y-axis represent volume. When you go up, this is inspiration, and when you go down, it will be expiration. This is the lung volume. Let's say this is your 0 and this is your total lung capacity 86 liter. So you are taking normal inspiration, expiration, inspiration, expiration, inspiration, expiration. Generally this value in a graph is your tidal volume. You see, now let's say you take a forceful or deep inspiration. So this is your forceful inspiration, and then after forceful inspiration there will be a forceful expiration. So this value is your IRV, that is inspiration reserve volume. This value is your ERV, and this value is your residual volume. This value remains in your lungs, preventing from collapse, and it does not participate in expiration or air transfer. So you see, this is your IRV, DV, ERV, and RV. Now this value is your ventilator capacity, which generally A normal lung is similar to force vital capacity. This value is your functional residual capacity. That generally the lung doesn't participate, but if when you take a deep inspiration, then this air comes into play. This is your functional residual capacity, and this is your TLC. So in a normal lung, this is the graphical representation. Now we take a flow volume graph of this. Let's make a flow volume graph. Here we make a flow volume graph. Now this y-axis is the volume and x-axis is generally is your flow. Here let's make this is your 0, this is 2, 4, 6, 0, 2, 4, 6. In this case, let's say you take an inspiration and there is a deep expiration. So this is your inspiration and this is your expiration. This is your expiration. So now here it comes out to be like this. This value is your residual volume, this volume is your vital capacity, and this is your total lung capacity. So in a spirometer, when you will process, this would be a normal graph of a normal patient or a normal lung. And now एक तीसरा ग्राफ और है जो वॉल्यूम टाइम ग्राफ रिप्रेजेंट करता है, दैट इज 1, 5, 10. That's 1, 5, 10. This is your volume and this is your timing. So there is considered 6 little here. So when you take a deep inspiration and after that a forceful inspiration, a forceful expiration, and that is your this is now your residual volume. This is your vital capacity, which totally come. This is vital capacity, and this when you have expire, this is your force expiratory volume in first second. So this is we are going on the x-axis. और ये समझने के लिए कि जब आप ऐसा गहरी सांस की और सिर्फ सांस छोड़ी तो दिस कम्स आउट टू बी your FE, this is 0, 1, 2, 3, 4, 5. So this is your FE1. In normal lung, your force vital capacity is generally more than 80% because the FE1 and this graph, FE1 is generally more than 80% or 80%, 70%. So according to this graph, your FE1 comes to be 4 liter and your FEC on this graph we assume that it is 5 liter and the ratio would come out to be 0.8. So you see, this is your normal lung where you look like this is your FE1, this is your FEC, and this is a second graph which you will find in your spirometry. Now in case of obstructive disease, अगर हम obstructive disease की बात करें, in case of obstructive condition, आपकी ग्राफिकल वैल्यू कैसी आएगी? तो ऑब्स्ट्रक्टिव फेज में हम जानते हैं कि टोटल लंग कैपेसिटी इंक्रीज रहती है, जो हमने पहले बात करी है. आपकी जो रिप्रेजेंटेशन है ग्राफिकल वो कुछ हद तक अलग हो जाएगी. जनरली टाइटल वॉल्यूम हम मानते हैं सेम रहती है और दूसरे से समझे इसको हम तो हम फिर से ग्राफ बनाते हैं. जनरली क्या होता है, in case of obstructive disease, your total lung capacity is generally increased, your IRV is decreased, your TB remains the same, ERV is increased, and RV is decreased. So let's say your RV is increased, your IRV is decreased, your TB generally remains the same, and here is your ERV. So in case of obstructive disease, IRV is decreased, TB generally remains the same, ERV is increased, or RV is increased. So here you will see a graph or this would be looking like this. Or just we say, if you take a deep inspiration and deep expiration, then it will become up like this. So you see, and क्योंकि ये बढ़ गया है तो now आपकी वैल्यू generally extend हो गई है. It may be increased depend on the lung capacity. जनरली इस केस में क्या होता है, जो आपकी FEC है वो भी कम हुई है, आपकी जो TLC है वो रेज हुई है और RV एवरेज. तो ये आपको ऑब्स्ट्रक्टिव कंडीशन के अंदर देखने को मिलेगा. इसी का अगर हम फ्लो वॉल्यूम ग्राफ बनाएं तो आप देखेंगे ये 0 है, ये 2, ये 4, ये 6, ये 8. Now the graph would shifts toward the right because your value was increased. So because RV is increased, तो अब आप धैर्य सांस लेंगे तो वो यहाँ से स्टार्ट होगी, यहाँ तक चलेगी, और this would be the value, or this would be the graph. Here you see the ventilatory capacity. This is your graph. Now this is your residual volume, which is now increased. This is your ventilatory capacity or force vital capacity, which is generally decreased. This is your expiration and this is your inspiration. So with this graph, your value comes out to be less and reduce, and your total lung capacity is generally increased. So we can see in this case it has raised to 8 or 7 liter. That depends. It is just a graph to show you the value. And there is also a king present, which shows that there is an obstruction during the phase. Now here you see, this is the graph which you will find in your spirometry. Now if we take the volume time graph of the same condition, obstructive condition, 1, 5 and 10, here is your 0, 1, 2, 3, 4, 5 and 6. Generally in this case, you will find the graph would be like this. Just a bit. The graph will be like number to make the graph. Your graph will be looking like this. तो आप ग्राफ देख के समझ जाएंगे your FPC has been reduced 0 to 5. It's come out to be here. Your FPC is reduced, but what the important condition is, your FE1 is per second is now reduced. FEV1 is 2. So if we put the FEV1 to FEC ratio, let's say it is 2 and 4, it comes out to be 0.5. तो आप अगर स्पायरोमेट्री ग्राफ में देखेंगे तो FEV1 FEC कम हुई और आपकी FEV1 फॉर्म हुई, और दिस वुड बी द ग्राफ प्रेजेंट इन योर वॉल्यूम टाइम ग्राफ इन योर स्पायरोमेट्री. तो ये समझने के लिए कि इस तरह से वैल्यू ऑब्स्ट्रक्टिव फेज में आपको कम देखने को मिल रही. नेक्स्ट, अगर हम रिस्ट्रिक्टिव डिजीज की बात करें, इस केस में हम रिस्ट्रिक्टिव डिजीज की बात करें तो restrictive disease के केस में क्या होता है? Your total lung capacity is decreased and your all the values are proportionally decreased due to lung damage. So in that case, you will see your RVs decrease, your ERVs decrease, your TV is generally same, and your IRVs decrease. So this is your IRV, this is your TV, this is your ERV, and this is your RV. And this area is now damaged, restricted, or damaged. So here your graph or the volume chart will be looking like this. A deep inspiration, and this. So you see, in this case, your FAC is reduced, the TLC is also reduced, and there is proportional decrease in all the values. So this is the graph of restrictive disease. Now if you make the flow volume graph for this disease, it would be looking like this is 0, 2, 4, 6. So in this case the graph will shift to the right because your RV is decreased and your TLC is reduced. So now you will have this type of error. Now you see this graph generally looks similar to the normal graph but slightly reduced. It's smaller than the and not like the obstructive disease. So here we see that this is your residual volume and this is your force vital capacity, which is residue, and it has come out from 6 to, let's say this is 5. It comes out to be 5. So here it was 6, in this case is what is, and here it is 5 liter. So this is the flow volume graph, and if you made the volume time graph, here the space is reduced. Let's go on, just increase the space by rubbing this. Now we make the graph here. In this case is 0, 1, 2, 3, 4, 5, 6. 1, it's come out 1, 5, 10. So normally what you will find here, the graph will be smaller. Now you see the graph would be look like here will be this. Now you see, so here you see the force vital capacity is reduced dramatically, comes to 3. Here goes 1, comes to 3. But your force expiratory volume, if we put it here, FEV1 is not so reduced, and it generally comes to 70% or 80%. तो आप देखेंगे, let's say this is 2.5. We make a value FEV1 to FVC. If we consider FVC is 3 liter and it is, let's say it's 2.5, so it will comes to 0.8. तो ये आपको समझ में आएगा कि ये ग्राफ आपकी रेसिड्यूज का है, और इस केस में आपकी एफिशिएंसी कम हुई है, आपकी एफईवी उतनी कम नहीं हुई, क्योंकि जो प्रोपोर्शनल डिक्रीज के कारण ये वैल्यू इस तरह देखने को मिलती है आपको। तो स्पायरोमेट्री में इसमें वैल्यू कम आ रही थी, 2/4 comes to 0.5, यहाँ पे 0.2 उठा रही है, तो आपको वैल्यू उसमें 0.8 लगी, पर लंग डिक्रीज हो रहे, लंग खराब हो रहे, ये वैल्यू नॉर्मल नहीं है, ये आपको ध्यान रखना है। सो दिस इज द graphical representation of this value to make you understand in the simpler way. I draw the graphs together. So you see, if I draw the flow volume graph, flow volume chart, the volume here is 0, 1, 2, 3, 4, 5. That's 0, 2, 4, and 6. Then the normal graph we make it 1, 2, 3, 4, 5, F6. Normally it would look like for a normal person, in a normal case. This is for the normal. In case of obstructive condition, because the value has been and TS is increased, so the graph would shift towards the right side. Make it just more good to understand. It would be your obstructive disease graph with the king present, and in case of restrictive disease, the graph would shift to the right, and it would be like just like so. This will be your comparative chart. It is for normal, it is for restrictive, and it is for obstructive case. And the same graph, it is the volume time graph. 1, 5, 10. It is 0, 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Here, a normal person, the graph is like this. For the obstructive case, it is like this. Or like this. Just I need to make it share like this. And in case of restrictive condition, it would be like this. So you see, it is for normal, it is for obstructive, and it is for restrictive case. You can see the FEV1 for FEV1 normal, for obstructive, and for restrictive. So this is basically the graphical representation of your spirometry chart and how the graph will be coming in the spirometry, and by looking at the graph you can understand the values. So the basic thank you, and we will be back in our next reviews. Thank you, and thank you for watching us.